have all the 16-bit, divide by 4 sections, convert it to hex. You got the same answer with the simulator, no? The answer should be 1200. Do you get the same thing? Means that you understand. Okay, now move to the next one. Move the W $345,234 to D4. Now you have to find its machine code for this particular command. The answer is 3839, but you have to get the binary number first. Right? The binary number. Follow the data sheet. Look at the command there. Try to fill out those 16 bits and then convert it to hex. Okay, the answer for that one, let's try and try myself. Move the W and D4. Move the W D4. Command, the first 2 bit is the same one. 0, 0. Size. Move the W, size is W. The next value is what? 1, 1, correct? 1, 1. Destination D4. Register number must be D4, which is 100. Mode is what? Mode is you have to look at the destination over here, right? Is the absolute long. $sign 6 number, right? So you have to look at the absolute long. Mode is 111. Register number is 001. 001, 111, and the source Okay, sorry. Sorry. That one is for destination. Destination is D4, right? D4 means you have to follow this one. D4 here. Mode is 000. Number is 4. 4 is 100, correct? 100. Mode 000. Source is the absolute long. You have to refer to this. Absolute long is this one. Mode is 111. This is default, is not right? This is what? Register, right? Size is what? Size is correct. Okay, 00 size is what? Move. Just say it's what? Move, no? The mode is based on which one? This one or this one? Destination. Destination is default. Mode is 000, correct? Yeah. This is register first. Register first. Oh yes, this is. Sorry. Okay, 00 size is move.w, there's another W. W is 11. And then this is the register number for D4. Destination is D4. This is equivalent to 4100. The mode is this one. 000. Alright? So the source is the absolute long. So you look at over here, absolute long is mode 111. This is 111. So this is 111 and the register is 001. Yeah. So divide by 4 sections. 3. So this is 9, this is 3, this is 8, this is 3. So the answer for the machine code is that one. You have to clearly state that this is a 16 base number in hexa. You cannot just simply put without a particular base number. Okay? Right, let's move on. Next question is move.long bracket A3 to D2. Move.long A3 to D2. So refer back to the data sheet. The first two numbers is the same one, 0, 0. Now fill up the next one. This is move.long. Long is equivalent to what? Long is equivalent to 1, 0. And then destination is D2. Destination, look over here. The first one is register number. Number 2 is 010. And the mode is 000. Destination 000. Now source. Source is bracket A3. Bracket A3 means you are referring to the source over here. Which one? 101. Which one? Which one? The bracket here, the address bracket here. The mode is 010 and the register number is 3, 011, which is 011. So again divide by 4, which is 2. The answer is 2413. Good. Hexapiece is a hex. It's a hex bit. Okay, agree? Your answer is the same one, with the simulator? So it means that every syntax have different data sheet. So what you learn today, you learn from clear and you learn from move. Normally, different data sheet will have the same contents, but maybe different format. You just need to know where is the 16-bit instruction and try to fill up accordingly based on the syntax. Look carefully, understand it before you try to fill up. This type of question is normally out in the midterm, because you need to know that how to read data sheet, how to make sure that you can compile the syntax to be a machine code. Now you have to understand, means that from here, so by right, this assembler, by right, this IDE 64K give you a lot of information basically. It gives you all the data register what happened. It gives you all the address register what happened. It gives you all the command lines here and the machine code which is reflects to the syntax. And also the locations of the memory where your program stored. When you write your program in simulator, I always use origin 1000, which means that I start my program at the location memory 1000 where I save my program over there. The CPU is only need to do execution based on the address where it points. So like for example here, right, I just want to do something. The one that very important here that you want to look is the program counter. In this simulator, program counter is showing you the current locations of the memory where it needs to execute. So now this one wants to execute at this line 1000 location. Program counter means that that is the locations that the PC wants to execute. So if I go next level, I go to here, you look at the program counter now changed to 1004. The next execution must be this one. That is the meaning of program counter. Counter means dalam bahasa Melayu is bilangan. Counter bilangan. Program bilang kat mana. You nak buat kat mana? You're counting your program. So right now, this particular information is very important because that is pointing the location where you want to execute. For this example, your program for clear.w is located at this particular memory. So that program counter will execute the memory, will go to the memory and execute it. Then you can do the clear instructions. Your CPU is only processing it. But the memory is one of the biggest things. You have to store your location. That's why when you learn Arduino or you learn all the microcontroller base, when you download the program, it stores to the memory. Then your CPU start to pointing to the memory and execute the program. That's the concept. But here is the RAM. Arduino is more on the ROM, where you burn your code. You burn the whole code, which is the machine code. You burn inside the ROM. Then your CPU will execute from that particular ROM. That ROM also have address. Now we are simulating based on our RAM, another memory, which is we give them the numbers from 00000 to FFFFF because of the 24 legs from the address pin. If you have more than 24, of course you can access more memory. Faham? Okay, next. So this one you know already how, right? So means that any questions on how to convert the assembly to machine code? Any question now? No. Every code has its own data sheet. The one that I teach you, I cannot teach everything. I teach you how to read the data sheet. I teach you how to use the instruction code. I teach you how to fill out. Different code, different data sheet. So no matter what I will give you, if I want to ask you the questions on the instruction code, I will give you the right one, anything, for you to look at data sheet and try to convert it. So every single syntax have its own data sheet. The one that I teach in the class, very simple one, clear and move. You can get no better other than data sheet. I try to post more data sheet in the you learn. You try look at it. Okay, we have few more. Any questions over here? Boleh faham? Semua dapat jawapan yang sama? Is the same answer? If as long as you get the same answer with the simulator, means you are correct. You can try other things and check it. No problem. Okay, let's move. So we have done this one, right? This lesson we have done before, right? We've done it. Make sure I've done it. Right now we move to here. Let's move. Okay, this is actually like a revision back on the syntax. The command is move.byte. Move.byte D1 to 2000. Move.byte D1 to 2000. So what the commands do? You look at the given data here. D1 contains this number. What does it mean over here? This means that at particular location at 2000, this is the contents. At particular this location, this is the contents. So you can draw it. At 2000 location, at 2000 location, this is 2000, 2001, 2002, and 2003. You can start to fill up based on this particular value. 99 will be at this location. $99. Next one, $00, $11, $77. That is the meaning of that one. At that location, that is the contents, and you have to fill up accordingly to the memory. One memory only 8 bit, only you can store. So now, this memory location have 99, 00, 1177. Move.byte D1, byte from D1, you have to take the last two from D1, which is FF, is the byte. Byte move to 2000 only, move to that particular location. Means that you are going to erase from 99 to FF. You are erasing the memory and replace a new number accordingly from the data register. Okay, next one. Boleh faham tak? The next one is between memory and memory, because it's a dollar sign directly, right? This is not through the address register, this is directly at the location to the location. So now you have to pick one. Move.w from 3400 location. It starts from that particular location. You have to grab W. W means 4 digits. From that particular location, 3400 is this one. You can draw like this again. So the first 4, 1122 is the byte, because it starts from 3400. You have to move W from this location. Take that one, put over here. W means word. Word is 4 digit. So from this number 3400, the 4 digit will be the first 1122, not at the back. This one you have to draw back the memory location. Words means 1122. Take this 4 number, then replace it at 2002. 2002 is over here. So then it replaced will be 1122. It will replace that number. So the final answer for this 2002 ialah 1122. Okay? Address to address. Last one, move.long. This is a region. Hash dollar sign the number here to D1. This is no sign extend rules happen, even though the first number is 8. Because this is not move quick, this is only move.long. So you just put the whole number 8899, that is word. But because of long, you have to consider the whole 32-bit. There's no sign extend rules happen. So you just take all 00008899. Okay, faham? This is mostly like revision. Move address. Move address is also another revision. Remember that if move address, if dot words, you are going to use sign extend. Because of move A, the destination is all address register. Move A. Without A means that it's just byte to register, that's all. Byte, register to register, data register. Because the final destination is address register, so the command must be move address. When move address, the sign extend rule will happen if you use W. Remember that W, you have to use sign extend. So right now it's move address dot long from this location 7000. Long means 32. Move address, the contents from 7000 move to A1. Given here 7000, the contents is this one. So you take the whole thing, put inside A1, that's all. The final answer A1 will be the same number from the contents at 7000 location. Okay, next one. Move address.w. Now you have to consider the sign extend rules. Move address.w, the number 3400. This is a number, not a location. This is number because of the hash. Okay, W3, the MSB for 3 is equivalent to 0. Okay, the highest one is 7. 8 is only 1. 7 still MSB 0. So means that the value 3400 will be put in A3 and the rest will be 0 because of the design extend rules. And the last one, move address the W, same number but now it's 8 to A4. 8 is equivalent to MSB is equivalent to 1. So the final answer is going to be FFF88CC. In these slides, you can see that the machine code is put over there. And you have to refer back here. This is not the data sheet, but part of it. This is the one. So you have to use the machine code format basically. Okay? The answer is there. You can do simulator also the same thing. You can refer back over here which one is which one. This one you have to fill out like this. This one you have to fill out how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 numbers you have to fill out. The rest is the same one. It's not the same like it will be different with each other. Okay? Understand? So MOVEQ also we already learned before MOVEQ. Okay, let's try. This is very simple. Okay, let's try. Okay, open up your slides. The slides over here. If you are exchanging two data register, given this number, if you are putting exchange, means that it's going to exchange, just swap the value between those registers, very simple. Exchange D1 and D2, you have this number, then you just change. These two, you just swap it. EXG, exchange. You just exchange it, very simple. And the last one is swap. Swap is only for the word swap D4. For example, D4 swap